Hi guys, today we're looking at day 12, so we should be finishing up our review, taking the test for that unit and section, and now we're starting a new one. So today we're looking at lessons 41 and 42. Okay, so lesson 41, we are finding a percent of a number. Remember, we've talked about how we can work from fractions to decimals to percents and bounce back and forth between all of those three. So today we're finding percent of a number. So new concept: to describe part of a group, we often use a fraction or a percent. We can use decimal, fraction, or a percentage, like half of something. If half the students got an A on the test, we could say that's half. We could say it's 0.5, or we could say it's 50%. Okay, if we're looking at this example here, 3/4 of the students voted for Imelda. Tim answered 80% of the questions correctly. So we can use fractions, which we've done and we know how to do. We can use decimals, and we can use percents. Okay, so some common examples that we have: percents, 25% of something. Percent means per 100. So if we have 25 over 100, that reduces down to 1/4. 5%, 5 per 100, 5 over 100 reduces down to 1 over 20. Okay, and we can convert those to 0.25 or 0.05 pretty easily as well. But today we're focusing on percents. If you're visual and you like to see, the circle graphs or some of these square rectangular representations, a 10 by 10 grid that shows what it's filled in, I think, again, it becomes a little bit more, it's visually appealing. It's nice when they have them, but it can take a long time to write this out for ourselves just to figure out 25%, okay, is 1/4 of the whole, okay, or 1/4, 0.25, or 25%. Okay, so let's look at example one. If we have 15% and we want to put it in decimal form, in my opinion, the easiest to work back and forth from is percents to decimals or decimal to percents. Because when we have a percent and we want to convert it to a decimal, really all we're doing is we're dividing by 100. And then when we're dividing by 100, we're really just moving the decimal 2 places to the left. So we could do 15 over 100, and then, convert that to a decimal. Since it's over 100, it would be 1500ths. That's one way to do it. But as we get, going, you guys will find through repetition, it's pretty easy to just move the decimal. If we're going percent to decimal, we move it 2 places to the left. If we're going decimal to percent, 2 places to the right. So 15%, we could write as 15. Even though we don't usually put in the decimal, we can after the ones place, just so we can visually see it. If we're dividing by 100, that means we're moving it 2 places to the left, because we're dividing. So it's getting smaller. It's moving to the left, making this value smaller. And then there's 2 zeros. So we're moving it 2 times. So 1, 2, and then put it right there. So 15% as a decimal is 0.15 or 1500ths. And if we want to move back to a percent, that's the same as multiplying by 100 or just moving it 2 places to the right. So if we had, let's do a little bit trickier one. Let's say we have 0.235 and we want it to be as a percent. Okay, we could go through the calculations. We could convert it to a fraction, then to percentage, and do all of that. Or we can remember multiplying by 100 is just moving 2 places to the right, and then it would end up right there. So 0.235 as a percent would be 23. There's my decimal, so 0.5, and then don't forget our percent. So we know that we're talking about percentage, part of 100. Okay, so it's just moving the decimal. That's why I think decimal and percents, you'll get to where you do it so much that you kind of just do it naturally. If 0.9 is 90%, you do it without even having to do the calculation or even write out the movement. For right now, obviously we'll do this, but as you get going, you almost just do it out of habit. Then we can use these percentages to figure out parts of a whole. So obviously percent is per 100, but usually a percent, we're talking about percent of the number of questions on a test, or my percent of the grade, or whatever it is, if we're talking about money or something like that. So in example 3, we have a word problem. What is 75% of 20? So what number is or equals, and then it was 75% of, which we know is multiplication, 20. Now, when we have percents, when we're going to calculate it out, we can't do 75 times 20 because that would make the number larger. We know 75% of something means that it's less than the whole. It's less than 100%. So our answer, we know without doing any calculation, has to be less than 20. So if 20 is 100%, 75% is going to be less than that. So we can convert 75%. In this case, sometimes it's easier to make it a decimal. Sometimes, depending on the equation, it's easier to make it a fraction. In this example, I think is going to be easier to do a fraction, and you'll see why. So 75%, we make a fraction. 25 goes into both of these. So it reduces down to 3/4. So now we can rewrite 75% as 3/4. 3/4 of 20. Okay, well, 4 goes into 4 once and into 25 times, and now we're left with 3 times 5, and that's 15. And that makes sense. 15 is 75% of 20. Okay? Or 15 is 3/4 or 0.75 of 20. It's just if we're calculating this out, if we're doing it in our calculator, you could put 0.75 times 20, you get 15. That's fine. But I think if we're doing it, especially by hand, 3/4 times 20, we can cancel out a 4, factor out a 4 out of both of them, and perform the calculation. So if you converted it to a decimal, that wouldn't be incorrect. It's just for that example, it might be a little bit more difficult, but still going to get you the same answer. If we're looking at sales tax, you'll see a lot of sales tax questions on tests, 6th, 7th, and 8th grade. So it says the sales tax was 6%, find the tax on a 12% purchase, then find the total price. So we have to add the purchase price or the subtotal, and then add the tax to get the total purchase price. So 6% of $12, so 6% of or times $12. Okay, well, I convert this. Since we're talking about money, in this example, I think it's going to be easier to convert this to a decimal. So sometimes fraction, sometimes decimal. Either way, you're just getting to the same thing, but since money, we take it out to 2 decimal places. Let's go ahead and convert this to a decimal. So I'm dividing by 100 or moving it 2 places to the left. So this percent becomes 0.06, not 0.6, because that would be 60%. We don't want to pay 60% sales tax. So 0.06 times 12, or 12.00, and that equals 0.72. Oh, where'd it go? So 72 cents. So that's the tax we're paying. So we had a $12 purchase plus 72 cents in tax. So we're paying in total, we're walking out of there paying $12.72. Okay? If you ever notice that if you buy something that's $1.99 at the gas station, you end up paying more than $1.99. So if you just have $2 to cover it, you're going to be a little bit short because of the sales tax that's on top of that. Okay, so that's the sales tax. Just convert it to a decimal. Read the entire question. Are we being asked to find just what the sales tax is, or what the total amount was of purchase price plus the sales tax? A lot of times we miss that. I have had students miss that on the test. They do the math all correct. They just didn't read the entire question. They solved for the total amount when we just needed the tax amount, or they found the tax amount when we needed the total amount. So just read the entire question. You may have that one extra step of adding the tax to the purchase amount. Okay, practice set we'll go over in class. And then 42, we're looking at renaming fractions by multiplying by 1. Again, we have to remember that any fraction, we can write any number over itself. We can write 1 as 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5. All of those are still equal to 1, as it shows right here. 2 halves is still a whole. 3/3, 4/4, 5/5, 6/6, they're all still equivalent to 1. Okay, so we can use that information to help rename fractions. So we're not changing the value of fractions, we're just renaming them. So if we look at the example here, 1/2 times 2 over 2 gives us 2/4. 2/4 is still equal to 1/2, so we didn't change it. 1/2 times 3/3, 3 over 6. 1/2 times 4/4, 4 over 8. So 4/8, 3/6, and 2/4 and 1/2 are all equal. Okay, so those are all equivalent fractions. So if we're looking down here and we have 1/2 equals what number over 20? Well, I know 2 times 10 equals 20, so 10 over 10 would still be equal to 1. Would keep the two fractions equal together. So if 2 times 10 equals 20, I have to do top and bottom by the same number. So 1 times 10 is 10. So 10 over 20 is equal to 1/2. And down the road, as the numbers don't always work out that nice and clean, we have another method which is called cross multiply and divide, or cross product, that we'll work with. But for right now, you should be fine with being able to figure out what you need to multiply by. So, and we'll use this also down the road when we're adding or subtracting fractions. We have to have common denominators in order to add and subtract fractions. So it's really important to be able to do this and make sure we're not changing the value of a fraction. So if I want to write 1/2 and 1/3 as fractions with denominators of 6, and we're told we want to have it over 6 for both of these fractions, well, I know 2 times 3 equals 6, and I have to multiply the top and the bottom by the same thing to keep it equal. Again, I want it to be equal. I don't just do 2 times 3. Well, 1/6 and 1/2 are obviously not equal. So I have to do 3 over 3 because that's equivalent to 1. 1 times 3 is 3. So I get 3/6. That's equivalent to 1/2. Now I know 3 times 2 because I just did 2 times 3. So 3 times 2 equals 6. And I have to multiply top and bottom by the same thing. So I end up with 1 times 2 and 3 times 2. Okay. So 2 over 6 is equivalent to 1/3. Okay, and we'll do these practice set problems when we return. So that's all you guys have for this video. We'll see you in class.